Welcome to Physics Easy. Today, we're unpacking a total visual masterpiece, the physics of the golden hour. Why are sunsets actually red? Let's get right into it.
Think about it for a second. The sky was brilliantly blue just a few hours ago, right? And we're orbiting the exact same sun. It hasn't changed at all. So why does that bright blue sky suddenly turn into a canvas of blood red and deep orange? It's a spectacular everyday mystery hiding right in plain sight.
Okay, clue number 1, unpacking white light. To solve this, we actually have to look 93 million miles away at our raw material. See, sunlight travels through the vacuum of space as electromagnetic waves. We call it white light, but that's kind of just a trick on our eyes. That single beam actually packs in every single color of the visible spectrum, traveling perfectly together. And here is the secret code of light: wavelengths. Not all colors travel the same way. Violet and blue light travel in super short, tight waves. Green and yellow are in the middle, but orange and red, they travel in much longer, lazier, stretching waves. Keep that in mind, because it's absolutely crucial.
Moving right along to clue number 2, the atmospheric filter. What actually happens when this pristine light hits Earth?
Well, our atmosphere is like a thick, invisible ocean. It's packed with nitrogen, oxygen, water vapor, and dust. The incoming sunlight doesn't just pass through cleanly, it totally crashes into this atmospheric soup. Which brings us to the core physics mechanism at play, Rayleigh scattering. Basically, tiny gas molecules in our air act like highly selective filters. Because they're so incredibly small, they barely even notice those long, stretching red waves. But for short, choppy blue waves, they act like a solid brick wall. Here's the math, but don't worry, no pop quiz today. It just means the shorter the wavelength, the more violently it gets scattered. At midday, blue light crashes into oxygen and bounces everywhere. When you look up, you are literally looking at scattered blue light raining down on you from all directions.
Okay, clue number 3, the long journey. Evening rolls around, the sun dips low toward the horizon, and the whole geometry completely changes.
It is all about distance. At noon, sunlight shoots straight down through a relatively thin layer of air, a very short path. But at sunset, the sun is shining at an extreme angle. It's coming in sideways.
Because of that super low, sideways angle, the light sometimes has to punch through up to 40 times more atmosphere than it does at midday. 40 times! That's a grueling marathon for that light to reach your eyes. So let's trace that step by step. Sunlight enters, and just like during the day, blue light scatters. But because the path is so incredibly long now, all that blue light is completely scattered away before it ever reaches you. It's just gone. What's left? Only the survivors, the longest, strongest wavelengths, the reds and oranges. They sail straight through the obstacle course. Let's step back for a second and look at real-world variables. If the physics is exactly the same every day, why do some sunsets look pale yellow, while others look like the sky is literally on fire? It's because our atmosphere is a completely dynamic, living thing. High humidity, wildfire smoke, or even local city pollution add larger particles to the air. These aerosols amplify that scattering effect, filtering out even more of the yellow and green light, leaving only the absolute deepest, most vivid reds and purples to paint the sky. Same sun, longer path, different story. I just love that. When you watch a glowing red sunset, you aren't seeing new light. You are witnessing an incredible journey of subtraction. You're seeing the tough, long wavelengths that manage to survive a brutal 40-fold atmospheric filter. So how might the specific atmospheric conditions right in your own city be painting your local sky tonight? Whether you've got extra humidity or city smog, your sunset is a real-time visualization of the air you're breathing. Next time you see that vibrant red horizon, remember the invisible physics making it possible. Follow Physics Easy for more amazing science.